Hello. Okay. Can you hear me? Okay, great.
Yeah.
So, hello everyone. I'm Yarden from NVIDIA, and today, together with Mai, we are going to present. Just a moment, I'm going to share my screen. The container hardening feature that we have for SONiC. So this is the HLD of this container hardening, and I'll go briefly through it. Just one sec. I want to see the chat here. So I'll briefly jump in, and then we'll go over the item list and the thing that we want to contribute here. So a bit of an introduction to this whole item. The SONiC infrastructure in general is largely based on containers. Currently, these containers are used as part of ramping up new capabilities, new features. The Redis is here, the SNMP, LDP, FRR, everything is based on containers. And the main item is that these containers are not security strict, meaning that these containers are basically just a simple encapsulation of the OS, and they do not pose as privilege limitations and containerization as the feature in our visibility should be. Our initial requirements can be scoped out to 5 or 6 main groups. The etc. is if there are additional items. We will be focusing only on 2, or maybe like up to 3. We'll be focusing on the privileges, we'll be focusing on the network, we'll be focusing a bit over capabilities due to the fact that we're removing the privileges. Mounting namespaces and C groups will not be the focus of this one. And as mentioned, if future requirements will arise, we can come back to this HLD, enhance it, and include these items as well. Architecture design, so I don't have a block diagram here because basically we're not changing anything in terms of the blocks in SONiC. We're adjusting them to accommodate to our security standards, or to security standards we see fit that SONiC should adhere to. The 2 main items that we have decided to focus at least on the first iteration is the root privileges, where currently every Docker container runs as root. And we would like to reduce that. So we are removing the -- privilege flag from the container itself. And this basically claims that we are not running as root. There will be an additional appendix and additional items down the line that you'll see what exactly changed between the current running containers and now that the container is running without the privilege flag. And another item is that we would like to remove the net host. Currently, all containers can see the full network spec of the host. This basically means that every packet can be seen by everyone. We do not have separation. We don't have network separation here. And at least the first step that we see that we can reduce this is not giving the container the net host, but actually using the net bridge and then performing port forwarding as part of host ACLs. That way we can basically claim that only traffic with specific ports which are destined, let's say, to the Redis will go to the Redis port. Only traffic that is destined to the SNMP will go to the SNMP port. And now let's say the Redis container won't see SNMP messages. Only when the SNMP tries to communicate with the Redis, either with Redis CLI or UDS, which is also a Redis CLI, there will be allowed communication between these two containers. By the way, another item that I want to emphasize in root privileges is that if a specific container is currently attacked and everyone is root, you're basically attacking the whole system. So let's say you have a vulnerability in LLDP. If someone can get hold of LLDP right today, they can basically attack the whole system. With this mitigation, even if someone attacks the LLDP, it doesn't take control of the whole host, just takes control of one container, and it reduces the threat of breaching the whole ecosystem. We'll go into a bit of a detail as to what we changed.
I have a question on the LDP and the example.
Mai, if you want to take over, and I'll scroll down.
Hello? Someone hear me?
Yeah, I can hear you.
So for the LDP container, can you explain what do you mean by, when you attack LDP, you only attack LDP container,
maybe
but not the whole host?
Mike, sorry.
Yaron, can you hear Google Hans?
I'm switching headphones, sorry. Can you hear me now? I don't know if I managed to solve my audio. Oh, sorry, my headphones were a bit jammed. Yes, can you repeat the question?
Oh, the LDP example, what do you mean by when they attack LDP, after your work, won't only attack LDP but not the host? What do you mean by, is this mainly on your first root privilege removal on the, namespaces?
So it's a combination of both, actually. Let's say that there is a vulnerability in the LDP container.
Sorry, LDP, I think you have to have a namespace as a host, right? So because they have to see all the front panel ports. There's no way, you can do a breach mode of LDP.
Yeah, but you can remove the privilege from LDP. You don't have to have the LDP running as
privilege part. Okay.
Yeah.
So therefore, I think still we have questions on the, name host namespaces. So what is wrong with that?
So let's say that the LDP container can retain the host network. Okay. I gave an example of a container which I didn't do a deep dive as to what needs to be retained. I can give an example of, let's say, now I don't have anything that is network accessible and we can remove the net host, maybe SNMP. SNMP, we managed to remove the net host and the privilege and it's still running. So let's say that SNMP container is breached. Now, if someone takes control of the SNMP container, it still doesn't have control of the full host. So if it wants to hop to root privileges, it still needs to perform some sort of privilege escalation on top of the container to do a container escape to the host and then do P to root. The mitigations proposed here are actions to make it difficult for each attacker to gain the highest level of privilege access on top of the system.
Oh, okay, so it's case by case, right? So it's not like every container you remove that. Okay.
No. It's not every container removing everything. I think there are also some examples here of PRs where we removed only the privilege flag and PRs where we removed the net host, and you can see examples here of what we managed to do. I won't go into each and every one of them, but just know they are there.
And another thing I think one pointed out is there's a lot of exercise being done on the in the multi-ASIC SONiC design. So, in the multi-ASIC system, some of the container has been already moved to the bridge mode. I don't know if any work has been done on that front to see what has been done on the multi-ASIC and whether those things can be leveraged in a single ASIC design or not.
I see. But I agree that maybe we can take it on a case-by-case container basis. We have a list of the containers, a long list of containers that we would like to reduce. I'm not presenting it here. I'm only presenting the design schematics of what we would like to do. Like the ultimate goal will be if each and every container can be without net host and privilege flag. Not every container can be that. Let's say BGP, I think, can't be without that. All these items, I agree. But this is the end state. And we are currently moving forward on a container by container basis.
But do we have a table like what container will do, what like that kind of table? Do we have?
Yes, myself and Chi and some architects, we tried to compose a table like that. And it needs updating because we had some old specs and it needs to be re-emphasized. We just did a brief of what we think can be removed and what not. When we're diving case by case, it will probably be further detailed as to what we can remove. But I can send a table as an additional appendix to this HLD.
Okay, thanks.
Okay.
Hi, I have one question.
Yes.
I understood that we are removing this privileged flag, right? So is there any feasibility done, like if we remove that, and will it impact in any aspect for the existing containers in the system?
So this is actually a good question. They say if everything goes smooth with this HLD, you'll experience nothing changed in terms of user experience, new bugs, or items that you couldn't do before. It will prevent you from doing, let's say, any actions that are not in the scope of the container. Let's say that you're in the Redis container, you want to create a new net device. The Redis shouldn't be able to do that. So in that scope, but if you're talking about current capabilities that are required for running SONiC, no, removing these flags should not harm your current running experience of SONiC.
Okay. But if we at least some high level impact or the scope of use cases that could impact if we can capture, I think that would be a bit of help.
So there is an appendix that we'll send it with this HLD, which states the capabilities that are removed when you're removing the privilege flag. It's not like a per Linux command basis, but it will give you a good overall estimation of what will happen when you remove this flag, and you can then assess if it requires some changes in the infra or not.
Okay.
I have a question. Is there any impact on RAM usage in case we remove those host netNS? Because it means we run the separate instance of stack, right?
It means that you run a Docker bridge,
on top of the host, which is already running. It's not something that is not created by default. And you're doing ACLs. The additional RAM usage should be as hard as creating a new ACL rule on top of the system, which should be negligible.
So doesn't it means that we will run like separate stack instance for the Docker container, like separate sockets or something like that? Because usually it means that you will not see the ports which you have in host network namespace.
Yeah.
So
I'm not entirely sure how does the default Docker bridge, because currently we're claiming that we're going to use the bridge network and not the host network, which is already existing. So you're not creating a new socket on top of the system. You're just using a currently defined bridge. When we tested, we didn't experience some sort of gaps in execution between host network and bridge network.
I see. Thank you.
It is not about running additional protocol stack, right? Okay, it's just about changes in network namespace, right? So yeah, actually, benefit, okay, in terms of memory should be pretty much negligible. Yeah.
Yeah.
Okay, thank you.
Okay. Mai, you want to talk about the privilege removal?
Okay, so again, I think one thing I want to comment on the namespaces, right? So I think a lot of work has been put into the SONiC multi-ASIC project, which does did a lot of enhancement and improvement on the container in terms of a network namespace. I think it would be, I would say, it would be a prerequisite to understand what work has been done at the multi-ASIC design term namespace before we start changing the containers to the bridge mode.
So we have tested this with multi-ASIC, and we have managed to run a full scope of tests, and we didn't see any drops or such when you go from single ASIC to multi-ASIC, even with the host network failure removal.
Well, so I think first is that, I think we need to unify the approach, right? So, for example, I think for the SMP and the telemetry, those containers has already been moved to the bridge mode, right?
Yeah.
So, then other containers which have to have access to the front panel ports, they have to be their own namespace, right? So therefore, some of the work has already been done. Whatever the container can be moved to the bridge mode, I would say, some of the obvious target like SMP telemetry has been already moved in the multi-ASIC mode, right? So therefore, I think, it would be helpful if we understand how the multi-ASIC design and then just leverage the same design for the single ASIC, right? So therefore, we'll have a consistent design, across the SONiC in terms of a different, whether it's a single ASIC or multi-ASIC, right? So I think I would suggest that would be the first step, right? So because it seems that some of the work that you want to do here to harden the container has been carried out in the multi-ASIC design for other purpose, right? So therefore, we should first understand how the multi-ASIC and then unify the design, right? So therefore, reduce the duplication work and make sure where we are taking the same approach, right? So the code will be more maintainable. So that is my recommendation.
Okay, note approved or received. We'll make sure that basically each container that we're doing the scope for, multi-ASIC will take into consideration. We see if we can combine or converge our work effort in that scope. Maya, do you want to briefly go over the privilege flag and what is written here?
Sure. So in this section, it's mainly to remove the privilege flag. Because this flag grants all capability to the container and significantly increasing its privilege. So a container breach could potentially escalate to a system-wide compromise. So to mitigate these risks, the container should run with the minimum Linux caps that they require to function. So without the privilege flag, the container will automatically have 14 default Linux capabilities. And we can even add more capabilities or drop unnecessary capabilities using cap add or cap drop flags to explicitly define what a container can and cannot do. So this granular control helps limit the potential damage if the container is compromised. Yeah, I think that's mainly about this section is. And if you scroll down, we can check the current capability in the container using the command cap /print, and it will print all the current content, all the current capability in the container.
Yeah. And we can see that the amount of capabilities has been greatly reduced from a privileged container to a non-privileged container. And as you mentioned, if we need to retain something like netadmin, which we saw a few containers, then we can add it in the runopt, as you mentioned. So this is the privilege flag removal. The net host is another topic here, where we remove the net host and we move it to net bridge. I have received a comment on top of the HLD as to why we're not using user-defined bridges or user-defined namespaces. And the reason why we're taking it step by step, we want to see first that moving to a bridge network doesn't harm anything here. And also the privilege flag doesn't harm anything here. Once we get a few more miles in traction with this feature, then we can further down enhance it to a user-defined network for each container, for a set of containers. Here we see that we have the Docker with hostnet sharing. And in order to remove it from the host network, we need to edit this flag where we can see that we have port forwarding here. This is specifically created with privilege flag, but we can create it without it. And here the network is changed to net, and then the database container is being port forwarded upon creation. And the way to check this is to go into the Docker and run interface ifconfig. With the host network, you'll see all the physical interfaces, and without the host network, you'll see only Ethernet FS and loopback ports. Any questions before I move on? Okay. I'm briefly going through all these items. There are no changes and effects to SIDE, to the DB, to the CLI, to warm boot or fast boot implications, and none that we saw. We tested it and we didn't see anything. Unit tests are not relevant at this level. It needs to be a system level test. I see that someone wrote if you can hear me, so no, I can't, and I hope I'm not the only one. I hope I fixed my headphones. Okay, I'm not the only one. I'll briefly go to the system test case, and then I'll try to answer if someone is writing anything. In the system test case, we can check and log into the container. We can run dev and see that we have no network devices. And in the privilege flag, we can see that we don't have access to etc shadow. how the upgrade works with this change. Do you mean upgrade from SONiC, from one version of SONiC to the other version of SONiC, right? I think that in this case, yeah, okay. So in this case, if we have an upgrade, it should be transparent to the upgrade, and I'll explain why. When you're redeploying the container, you're creating it with the Docker file, and basically your database, if you retain the database, it will remain the same, and only the container environment runtime will change, but it will have no effect on, let's say, non-volatile items such as the database. And also the net host is the same. So we did not see any impact when we upgraded from a non-secure version to, let's say, a version with when the Redis didn't have the privilege flag. So I don't see any problem here.
Here I have one more query. So when we say upgrade, either it could be the complete SONiC system upgrade or any specific Docker package upgrade. You mean to say when there is no impact in both the use cases?
Yeah, because even if, let's say, if you're doing like a Docker upgrade, you're basically restarting the Docker container, right? You're not doing like an on-fly without Docker restart item. So when you're doing the Docker restart, you'll also get the new requirements for the Docker, and then you'll rerun it in the secure mode. Unless I have a misconception of how or let's say you port it in some sort of specific manner where some sort of Docker requirements are not being pulled, but I don't see how. You'll still get the Docker runtime requirement and load it as an unprivileged container.
Okay. So a restart should resolve any dependencies.
I think so. I have not tested this edge case, but I think so. We can try it with any of the current PRs that we currently have in the system and check that. Like there are currently PRs in the system on the main branch that we can try this if you'd like. Privileges P1 container. Yes, there is a list of containers where we want to remove it. Pmon was a bit on a lower priority, but we can do it as well. If someone has a specific container that wants to question ask, then let's do it on a per container basis, and not this full HLD, because I can't go into each individual container here. Okay. So the current open item is that by the way, this HLD was created a bit a while ago. So when we created, we had only the Redis and SNMP. And what we'd like to request is that there are a bunch of other containers on top of the system, and we'd like to address the community to also assist here in reducing the container privileges of each container. Not all of them are 100% visible to us. So this is why this is written here, and we'll address it later on. Mai, do you want to go through one of the appendixes and expand on it?
Sure. So this appendix, first table, table 3 is the all Linux capabilities. So there are about 14 Linux vulnerabilities. So without the privilege flag, there are these 14 capabilities, and you can drop this capability using the cap drop flag. And the below table, table 4 is the extended Linux capabilities. So for this table, Jörn, can you scroll down? So for this table, without the privilege flag, there will not be any these caps, and if you're using the privilege flag, there will be all of the caps in this table inside a container. And for our design, I think for most of the table, we will remove the privilege flag. So essentially we're gonna drop all of the caps on this extended table, and we're gonna keep one or two caps like net admin, which is to perform various network related operation, and also we may keep the sysadmin, which is to perform a range of system administration operation.
Yeah. I'd like to mention that currently we saw, I think, only that we needed to retain the net admin. We didn't see any other capability that we need to retain on the containers we have currently run upon. This is the end of the HLD. If anyone has any additional questions.
Is there a monitoring available to flag any containers running in a privileged mode, or any kind of notification, access log?
There are tools to test it, but I'll give a brief answer. Currently, all containers are running as privileged. All containers off of SONiC are running as privileged, except the ones we reduced. There is a test that that they have written here in the SONiC management, where we can expand. Let's see, where is it? Here, where we're testing that the specific container to remove the privilege from is running as a non-privileged. And we can expand this list and test that this test is going through. But other than that, we have nothing. Yeah, sorry, we need to.
Would it make sense to add something similar? Over a period of time, I think the goal is to reduce the privilege mode for most of the containers, right? Maybe there will be some exceptions. So maybe you can have those containers which are exceptions, but flag in a way we can identify other containers.
Yeah, we can discuss it and leave a comment, because I just got a message that we need to leave time for the next HLD. So if anyone wants to leave additional comments, I'm available. This HLD is open, and we can review it.
Sure.
Yeah. Okay.
Okay, thank you.
Thanks a lot.
I hope you guys can hear me. So, Swana, I think you can go ahead.
Hi. Yeah. Let me share my screen. Okay. Are you able to see my screen with the document?
Yeah.
Okay.
Yeah,
thank you. Okay. Hello, everyone. So today I wanted to discuss the changes that we have done to support SNMP over IPv6. So the IPv6 was already enabled in SNMP daemon that is running inside the SNMP Docker, but we found some issues with respect to SNMP query over IPv6. So this document is to capture what was the issue seen and what is the fix that we made to overcome this issue. So this issue is mainly seen when we have multiple IP interfaces on a device. So what was happening was SNMP query was failing whenever we send the query over IPv6. It was timing out. So just to go over a brief understanding of the SNMP configuration, specifically on the IP address part. So today, SNMP daemon process is running inside the SNMP Docker. It uses this snmpd.conf file as a configuration file. And one of the directives inside this configuration is the agent address. Agent address defines a list of IP addresses that is used for SNMPD to listen on, and we can receive any SNMP request over this IP address. The other method is used to configure or to add IP addresses is to use this config CLI. So the config CLI adds any IP address, and there is a entry made in the SNMP agent address config TP table. And that config.db table is used to populate the SNMPD configuration file. And when SNMPD restarts, it starts to listen on the newly configured IP address. So this is how the current configuration is done. So in the current configuration, what we do is we first check if there is any agent address that is configured via the config.db table. And then if yes, then we'll use that to listen, or SNMPD will use that to listen. If not, we'll just listen on any IP. We don't specify any one single IP, but we just listen on any IP that is configured. Any IP that is configured on the device. So with this current design, what is the issue that we see is that IPv6 query fails. And why does it fail? Is because when SNMP request comes in, when the SNMP response goes out, it uses the incorrect source IP address. That is the main reason why the SNMP over IPv6 fails. So let's see the packet capture here. So here what we see is that SNMP request, it comes to the loopback IPv6 address, which is the :32. But when we see the response going out, it uses the port channel IP address instead of the source loopback IP address with which it was the SNMP request was destined to. So this is the main issue with IPv6. Here I have listed down the sequence of what is happening. So basically the request comes in and SNMPD processes the request. And when the response goes out, what it does is that it looks up, it does a route lookup of the destination of the response. And when it does a route lookup, at that time, it uses whatever is the best source IP address that the kernel gives it. So at this point, we have lost track of what was the exact destination with which the request came in. So what is the main root cause of this is that SNMPD, which is the SNMPD daemon which we use from the NetSNMP code base, that is not keeping track of the destination IP with which the request came in. So we lose track of this destination IP, and this happens only in case of IPv6. In case of IPv4, SNMPD tracks the destination IP address with which the request came in, and it plugs that in the response packet. So IPv4 works fine, but in case of IPv6, this linking is missing in the SNMPD code. So this is the main root cause of
But I'm not sure this is SMP problem. This is SNMPD problem, right? So
that's
in
correct,
RFC,
Gohan, yeah.
there's a weak mode and there's a strong mode in terms of you have a multiple interface when you return a packet, which source IP do you use from those interfaces, right? So
Correct.
but I'm not sure this is SNMPD's problem.
Sorry, it is
I'm not
not.
sure.
So
I'm not sure the SNMPD need to track, okay, which request the source IP is coming from. Therefore, when I return this response, I have to return the same source IP. I'm not sure. That's a model
so,
how.
From my understanding, from the going through the code, what I have seen is that it does do that. SNMPD does handle taking care of forming the response packet correctly with the correct IP address in case of IPv4. And I have given some code pointer here. And there is also a way in which the response packet structure is organized for IPv4 to provide the source IPv4 address. But the same thing can be done. The same thing is there for IPv6 also. There is a provision to do that in the Linux IPv6 packet formation also, but that is not handled in SNMPD. So that is my understanding based on the.
I saw there was a routing configuration in terms of Zebra, right? So you can set the source IP for the kernel routes. Therefore, once the packet, because usually, this is a UDP, right? So it's connectionless concept. So there's no kind of a connection concept. You don't have to use the same source IP when you send the response, right? So whatever the source IP you can use, you can.
Yeah.
as long as you reach a destination, you can do it, right? So
Yeah, but
therefore, you
in
know,
case of SNMP, the issue is that, like, I think in case of Zebra, probably it is we can set a source IP and for the packets that are going out, but probably that source IP is just a one single IP in all scenarios. Is my understanding right? Because in case of SNMP, we can use either the loopback IP as the source IP in the response, or we can use the management IP if the SNMP query came over the management network. We could use even the front panel, like any of the Ethernet or port channel IP interfaces as a source IP. So we can use any IP from as a source IP in the response based on how we receive the request, right? So we cannot set a specific source IP like one stop for all packets in case of SNMP response that is going out, right? So there should be some way in which we should know that the destination IP in the request was so and so, and we need to use that destination as the source in the response packet. So we could not set one single IP, right?
Dad.
Hi, Suwana. I see
Yeah.
this next question is about the multi-ASIC is pretty okay. No such kind of. So
Yeah.
do you mean that if the same comment to Yarden is if we unify the single ASIC and multi-ASIC of the SMP container, the net mode. So if that happen, so the issue will disappear, right?
So I think so yeah, I think we might be able to come around it, but then we will have to add an additional internal. So right now we have done some changes to send the SNMP packet request packet that is coming in from the loopback interfaces, which is part of ASIC namespace, and send it to the SNMP Docker, which is running on the host namespace for multi-ASIC. So there was some changes done for that, and I have tagged the PR here. So probably if we move or make the change for single ASIC or for all platforms to use the net container in the SNMP Docker, then we might have to make some changes in terms of sending the packet correctly to the SNMP Docker running on a different namespace, and just like how we have done for multi-ASIC, and then we might not see this IPv6 issue. That is correct. Yeah.
Yeah, I think the main point is the difference between a V4 and a V6 behavior from SNMPD perspective, right? Even though routing table, the kernel behavior is same. Like the route is there, the source IP in the route entry is there, but somehow when for a V4 it picks the IP of the incoming packet, like when sending out, but for V6 it picks the routing basic routing based. So that's the delta between V4 and V6.
Yeah.
So this is part I don't understand, right? So go ahead, yeah.
Sorry, go on. Swarna, did you check the net SNMP perspective? Whether is there any known issue? Because this seems to be the very basic one. I don't know if we are missing something.
Net SNMP, yes. So actually, I think recently, there was a similar issue reported in Net SNMP GitHub also, telling that SNMP over IPv6 does not work because in case of multi-NIC environment, and this is exactly the same issue that we are also talking about. And this seems to be an issue in the NetSNMP code base also. And I think probably the person who reported is trying to work around this issue in NetSNMP itself, like have a way in which the correct source IP address is added in the response packet. So that would be like the base fix, right? Resolving this in the NetSNMP code base. But yes,
I want
this
to
seems to be
understand
like
what's the problem. What's the problem for using a source IP from the host return packet back?
Right. So if we use a source IP, then what happens is that, let's say that SNMP request comes from a neighbor, directly connected neighbor, and it is destination is the Dutch loopback IP, and we receive the request, and when the response is going out, we do not know where which is our source IP at this point. SNMPD does not know whether it is the management IPv6 or loopback IPv6. It just knows that it has to send it out to the source IP, which is the colon 72, right? So what it does is the kernel route lookup happens, and we figure out that it is a directly connected port channel IP link that it finds, and the source is our port channel, the Dutch port channel IP address, IPv6 address, which is 71 in this case. So it uses this source, which it gets from the kernel route lookup in the source response packet, and that is. And same thing, like if you flip around and
what's wrong with that? No, then what's wrong with it?
Oh,
I mean,
yeah.
is the
So
packet
what is
not able
wrong?
to reach
Yeah,
to the
yeah,
receiver or
correct,
requester, or
yeah,
what is wrong with
yeah.
that? Yeah.
So
No,
when we
what
send
is wrong?
out, yeah, so when we send it out, when we send the response out, it goes out of the same interface with which it came in, which is fine. In this case, it goes out of the same interface with which it came in, which is fine. But when it is going out, I think the receiver is not able to interpret as the right packet, because it is
Why?
not the correct source IP address with which it was. So it was expecting, because the destination of the request packet was something, it is expecting the source also to be the same thing of what the destination was. And this is in this particular
UDP is a
scenario.
connectionless concept, right? So this is not TCP. There's no concept of
Correct.
connection, right? So
Gohan, in this case, we are it goes out of the right interface. But in case of some other environment, right?
No, I don't care
we
about
can,
whether it's the right interface or not. It doesn't matter to the receiver, right? So, but
no, it
didn't we
matters.
check the receiver? Why? No. Didn't we check the receiver why it has to know the source IP of the packet in order to know? Isn't that in the SMP payload itself? You have the identifier can identify which
Yeah, I think
which
in this
device
case,
is coming.
yeah, SNMP walk was failing. I don't think we looked into the SNMP walk client itself, right? Why it was ignoring.
Correct, yeah. But Guhan, in this case, it's let's say that if there is a request that is coming via the management interface, right? We also saw some scenario in which the request came through management interface, but the response went out of the loopback interface because the kernel route suggested. So then it is
Actually, it's
not
by
the
design, right? So, no, how do you know this is not right? This is by design. As I said, in the RFC, there is in terms of a multi-NIC scenario, there were two models. One is a weak model, one is a strong model, right? So I think, we should look at what's the model here. I believe, what we have do in here in the multi-homing scenario is we are using the weak model for SONiC.
I see. But
still, traffic coming on management network and going over a data plane network, that will not work, right? It depends on environment to environment, but it will not work, right? Because the network itself can be.
Theoretically, it should work, right? So as long as the packet can reach back, right? So of course, I think in routing, in terms of routing, there's a symmetric routing, there's a asymmetric routing. We didn't say that asymmetric routing is not working, right? So it is working. I mean, I think the problem really boils down to we need to figure out whether this is a client issue or not, right? So if client is able to differentiate, where UDP is connectionless, right? So therefore, the client should be able to differentiate, which kind of identifier in their payload. It doesn't have to rely on the source IP, right? So, however, if you say, okay, hey, SMP, the protocol has to rely on the source IP to know what was the target, right? So then that's a different problem, right? So I mean, are we saying that? Is that defined in the SMP protocol? Saying, okay, they have to, leverage the source IP. If not, then I think, either way should work, right? So.
Right. I
mean,
can
that's my point. But
actually.
So Suvarna, have you documented the two drawbacks because of the solution? One is like previously, if SNMP was kind of running listening on any other interfaces apart from management and loopback, it will no longer continue to work with this solution.
Yeah.
Second
Yeah,
is
I've not.
if
Yeah. Yeah. Go ahead.
second is if the management interface is as IP is obtained through DHCP, this solution doesn't handle, and it requires management
Yeah.
IP to be configured through the config DB. So
Yeah.
this has some backward compatibility issues as well. So I'm not sure if there are production environments that will get affected because of this change, but we need to consider that too before going to the solution.
Yeah. So
I think that was also addressed, right? I don't know whether it's covered in this design or not, but I think those
the
comments,
DHCP is not
Sudarshan, I
addressed.
think they were.
It's not addressed. I think both comments are not addressed.
No. So we have mentioned. So documenting the change. Yes, I have mentioned it. The
Yeah.
DHCP is not working. Working. The issue is not fixed, but I've mentioned the issue here.
Okay.
So yeah.
So
I mean, yeah.
Yeah, the documenting is one thing, but we would like to know like if there is any scenario where if there is a front-end interface that is where SNMP is working, and it may kind of like even for out-of-band management interface, right? If there is something configured that way, this solution will not work. And the management appears to be a more straightforward use case. And if someone runs a DHCP over it instead of the management IP, I think there will be a problem with this approach.
Yeah, so let me just go. So Gohan, like probably I will check on the client side, and also if SNMP protocol itself has some definition of whether the source IP has to be managed or like it has to be kept track of. I'll check on these two questions. But to continue and to go on with Sudarshan's discussion, I'll just go over what was the change that we did to fix this issue, right? So to fix this issue, what we tried was if we right now we have this we by default we listen on any IP, and if there is no IP configuration in the SNMP agent address table. And so instead of doing that, if we listen on specifically the management IP addresses and loopback IP addresses, IPv4 and IPv6 separately, then this issue is not seen, because what is happening from SNMPD side is that SNMPD binds to separate different sockets for each of the IP addresses that we have specified in the agent address configuration. So in this case, what happens is there is a separate socket create binding happening for IPv4 management, IPv4 loopback, IPv6 management, and IPv6 loopback. And and whenever the SNMP request comes in, it goes on. The request is received on one specific socket, and the response goes out of the same socket. So that takes care of sending the SNMP response with the right source IP, and that resolves this issue. And that is the fix that we have made. So what we do is we listen on we look at the config DB, and any management and loopback IP, loopback 0 IP configured in the config DB is what we use when SNMPD comes up. So that is a change in the default behavior. So by default, SNMPD will be listening on management and loopback 0 IP addresses configured via config DB. And if there is no configuration provided, or if there's no IP address configured in the management or loopback, then and also if there is no configuration added via the SNMP agent address table in the config DB, then the last option would be to listen on any IP. And of course, like all these, any specific IP that we want to listen on, we can always use the config CLI to configure to listen on any specific IP. So that is the main effect of this change. And as Sudarshan mentioned, there is one issue that we have observed with this change. That is, if DHCP is used to configure the management IP, then the SNMPD will not be listening on the configured management IP, because when SNMP Docker comes up, it will look at the management IP configured in the config DB. It might not find any management IP, and it will just come up listening to the loopback 0 IP. And later, when the management IP is configured via DHCP, by then SNMPD is already up and listening on the loopback 0 IP, and it does not listen on management IP. So that is the issue that we see with this approach. So there is a possible solution that we had discussed with Chi and Sudarshan, and one way is to have a daemon updating the state DB with the configured management DHCP configured management IP, and then we can have SNMP modify to listen to the changed IP address and then restart the SNMP service if there is any change in the management IP. But this is more like a another new design that we will have to do. So this is
yeah, thank you, Suvarna. My question here is it okay to have this backward incompatibility, or should we investigate the SNMP client first and maybe not work on this
I think
solution?
that's what I'm also thinking. I think you're right. I already commented in the HLD that we should look at NetSNMP code to fix this issue. What it takes to, because it's working for IPv4, right? So for V6, why is it that IP packet info, whatever the structure that we are passing to the socket, right? Why not we pass the source of the query in that destination of that query, whatever, to get the right source address, right, for the response. So I think if we do that, things would be working fine. And in terms of listening for that particular management and loopback, I think this will break for other vendors, because we depend on other inbound interfaces for SNMP to work and all those things, right? So if you change that default behavior, this will break that whatever the things working already. So we would like to have whatever the current behavior is as is, and then if at all you want to listen on loopback or management, have it as a configuration specifically for SNMP. Don't change the default behavior in the SNMP. So that would work for all other cases that we have.
Quick question. That's my opinion too.
Quick question: Does IPv4 work because IPv4 choose the right source IP, or does it because the client of IPv4 doesn't care the source IP?
It shows the correct source IP.
Yeah.
Okay.
Yeah, I think that the server probably in certain deployment probably might have some assumptions on basically the response should come back from the original router that it tries to query, right? But I think that might be, I think that probably was this proposal is trying to address specifically.
Yeah, so it's worth to investigate into the protocols, but I mean, in the world of interoperability, there's no black or white. There's a lot of gray things that we have to work on. I'm not saying that this HLD should just go through as is. There's alternatives, right? So, like for instance, if we can configure a list of interfaces to listening on instead of the IPs to listening on, would that be more flexible? Let's say I want to listening a management port Ethernet 0, right? So then the SMD can query if this interface is up and does it have the IP configured. If it does have IP configured, listening on that IP instead, or just bind to that Ethernet 0 instead.
That is not an option in the SNMPD configuration. I did check for that. We cannot just use an interface. So when SNMPD comes up, we need to have a valid IP address that is associated with a specific interface. And when SNMPD comes up, then it tries to bind to that IP address, whichever we have tried to configure using this agent address. So we can only provide IP address list. We cannot provide interface names.
Do we own that code? We don't. Can we write a wrapper to start that agent?
We could try to modify. I mean, we could try to generate this configuration file when SNMPD starts up in certain ways that we want to, because right now this configuration is actually a Jinja template which we render when SNMP Docker comes up. And when the Docker is coming up, we could, try to find out based on the list of interfaces, what are the IP addresses configured. But again, this will be done during startup of the SNMP Docker. Like later on, if DHCP is going ahead and configuring an IP, we might not be able to use that IP unless we are listening to the change in some place specifically. So this issue will still be there about if management IP being configured from via DHCP, that issue will still be there.
Yeah, that was because the server IP was configured from the smpd.conf, right? So what if it's dynamically learned?
So I just look at the.
Yeah.
Sorry, maybe we should take this offline. I have to drop another meeting. Sorry.
Okay. Yeah. Thanks. Yeah. Thanks.
Thanks, folks.
Guhan, did you have a suggestion? No?
I have some audio issue.
Oh, okay. Okay. So yeah, I think I will definitely check the client side part, and also if the protocol really requires the source IP configuration. But apart from that, yeah.
One question I had, like from Sudarshan comment, like, do we have to maintain backward compatibility for DHCP or other mode for IPv6? Has this been running somewhere, or it was the comment was mostly for v4 backward compatibility?
It was for general backward compatibility on the behavior of SNMP. Currently, we don't have kind of any DHCP solution that needs to come as a separate solution. When we obtain management through DHCP rather than static configuration, we don't update it anywhere. So the suggestion here was we need a feature where we update the DHCP IP into StateDB, and SNMP later listens to it and updates its behavior to restart. But that's a altogether different solution.
So for now, if basically till now things might be okay, because if you do on 0.0.0, then we don't need that one, right? That's the
correct. Currently we don't specify agent IP, but with this solution, when we specify agent IP, this might be an issue.
Correct. Yeah. Now I was trying to understand, like, is some v6? I don't know whether v6 is anybody is using, or well, will this change cause any issue with v6 also?
No. The thing is, yeah, when we specify the agent IP, it is specifying for both v4 and v6. So this will break the backward compatibility of v4 as well. That's the concern.
Yeah. That part we have to see. Yeah, maybe if we can't find a client side solution or the server side, maybe then we should try to see how can we make only for v6 for now.
Okay. So I'll explore those couple of options, and yeah, if there is any other comments, please do update the document PR. Yeah, that's all I had for today.
Okay. Yeah. Thank you. Yeah.
Thank you.
Thanks, Suwana.
Yeah. Thanks. Thank you.
Thank you.